Hello everyone, welcome to UNC Digital Classrooms. On today's lectures, I am going to discuss one of very important fact of the computer graphics field, that's your basic illumination models. So, here is an abstract outlines which I will discuss in today's class. First, I will discuss about the briefly concept about illumination models. Then after I will discuss the different components, important components of the given illuminations models. Then after I will discuss how the object to be illuminated by using different properties like your intensity of ambient light, by using your types of object surface and by using your surface colors. So now to start our initial concept, what is illumination models? Here the illumination models, a real world image taken by digital camera will only capture a small object of the light rays passing through a small area, and after that also we have to check upon a approximation views is generated using complex formulation and algorithm. That means the illuminations models to be known as light models, or sometimes that is to be also known as shading models. That means here the illumination models to be used for calculate the intensity of the given light sources of a single object, and also this light intensity to be calculated or measured by using one algorithm that is to be known as surface rendering methods. And by using this given surface rendering methods, here it to be calculates all over the pixel points of the given object individually one after another, and what are the highest resolution intensity that to be calculated by using this intensity the full pictures to be scanned, and this is to be possible by using one concept that's to be called as illumination models. Now goes to our next concept, that's your hardness of illumination models. That means when the illumination models to be calculates the light intensity which is to be reflected from a given surface of the given rendering object, in this case some difficulties to be comes. The first difficulties here, that's your a object is illuminated not only by direct light source but also from the light which is inter-reflected from nearby objects. Then after another one hardness to be arises, that sure there can be infinite number of light rays coming from the nearby object to illuminate the object, and also here the illumination models, it is very hard to find out all the inter-reflected lights. When any types of database for these lights rays is not possible, that means for creating a database for these light rays is not possible. Then after here also the image created after considering illumination models in only close approximation of original image, and the illumination model also to be try to capture a set of light rays which reflected of inter-reflected from the various object so that a close approximation of original scene can be created, and finally that we gives the actual reality of skins which is not to be possible, only that to be viewing some abstract concept of the object, that means some partial portion of the object that to be viewing which is to be reflected from the given source of light. That means here the light sources cannot be only natural light from sun or moon or stars, but it could be man-made devices like bulb or tube or any highly polished surface. Here the light sources are referred as luminous object, which are objects that emits radiant energy, and they can be both types light emitting source which could be any types of points like your diffuse or distributed object emitting radiant energy, or any light reflecting source, any types of polishing area where the light to be reflected. That means the illumination models to be whenever to be scanned all over the given object where the light to be reflected from the given surface, in this case some difficulties to be arises. That means whenever we have to scanning any types of object by using illumination model concept, here the given object to be compulsory to be placed above the polished object like any types of opaque models elements. For examples, it always cannot be executing through the help of light sources. It also executed some man-made devices like your any types of electric valve. Okay. So now goes to our next concept, that's your mathematical illumination model concept. That means what are the components to be required for calculating the intensity of the light sources of the from the given object. The given figures to be represent one type of illumination model concept, that's your specular reflection directions. That means here the object to be viewing one of the given surface which is to be very strong for reflecting all over the light sources in every directions. Okay. It contains three types of elements or components. One is R. R represents the unit vector in the direction of specular reflections. That means when the light to be reflected above the part of object, then whatever the incident rays that to be reflecting through this, another object to be view up, and that to be possible by using your vector R. Then another components that to be holds, that's your L. L to be indicates unit vectors directed towards the point light sources. That means it indicates the location where the lights to be comes. And another components that's to be contains, that's your V, unit vector pointing to the viewer from the surface positions. That means here that to be viewing where the given viewers, the users to be viewing in which direction from the given object. Okay. And lastly, it to be provides one angle value of pivot elements as the viewing angle relative to the specular reflection direction R. That means in which positions the user to be viewing all over the object, and also in which angle the user to be view up, that to be calculated by using your angle theta. And lastly, it to be compulsory viewing all over the object in every directions if the object space to be 3D flaps. Okay. So now goes to our next concept, that's your illumination models. Now goes to our next concept, that's your illumination models, in which way all over the light that to be reflected. In general way, in case of illumination models, light sources to be reflected from the given object in three ways. The first one is that's your point source, and the second one is the parallel source, and the last one is the distributed source. So what is point source? Here the point source means it is a simplest models for a light emitters. That means here rays from source follows radically diverging path from source to the positions. For examples, sources such as LED or small bulb or any types of torch material elements, that is, these are the light sources in which light rays originate at a point and radially diverge, and such type of sources have dimension quite smaller as compared to the size of the object. And here the source A is the point source. That means suppose here the source point V that to be directly focusing from the given object, and if that to be directly focusing this point to object for viewing another object, so in this case we have to know as this types of mechanisms to be point source illumination models. So now goes to our next models, that's your parallel source. The parallel source means if the point source is at an infinite distance, then the light rays are parallel and acts as a parallel source. That means suppose here the vector points S, and that to be that cannot be counting due to long distance. That means when any object that to be view of by using any long distance sources reflected light, in this case we cannot be calculating all over the infinite range distance. In this case all over the light to be focusing on parallel way. That means here the light sources to be created by using some parallel lights from every directions, and in this case this type of model to be known as parallel sources. And another one default sources concept that to be uses, that's your distributed sources. That means this models nearby sources such as the long fluorescent light are modeled in category of distributed light source. That means here all light rays to be originate at finite area in space, and by using this space light we have to viewing another types of object. That means for examples in case of distributed sources illumination models, suppose you have to on any types of light sources bulb, and that light sources to be reflected any types of opaque object, like your for examples mirrors. After that, when the mirror to be observing all over the light source through the electric bulb, then after the mirror also to be reflecting some light through the wall, and the wall also to be viewing all over, and also the wall to be viewing all over the given areas information through the distributed lights, that's your mirrors. And this process types of illumination models to be known as distributed illumination models. Now goes to our next components, that shows protocol models of the illuminations. That means by using the concept of point and distributed and parallel, we have to use another some mathematical models through which we have to easily calculate all over the intensity of the light sources given object. The first one of illumination models, that's your ambient light illumination models. That means here in case of ambient light, a surface that is not exposed to direct light may still be lit off by reflection from other nearby object, that is to be ambient light. That means suppose here the one types of light bulbs that to be focusing, that to be reflected from the any types of dome materials, and by reflecting this dome materials again we have to viewing another types of cube object, and this types of process to be known as ambient light. That means by using some nearby object which is to be reflecting all over the light sources, by using another light, and then after it to be providing the light to viewing another object, nearby object, in this case we have to known as ambient light. In case of ambient light, compulsory when we have to viewing any types of object through the help of reflection light bulbs, here the reflection lights to be focusing in a given object area that to be opaque in natures. Okay. After that, when the light to be reflected this opaque object, then the object to be creating some reflecting light, and by using this reflecting light, if we have to viewing any nearby object, in this case this types of model to be known as ambient light. Okay. That means here the ambient light has no directional or spectral characteristics. That means in this case always the amount of ambient light incident on each object is constant for all surface and for all directions, and the amount of ambient light reflected is dependent on the properties of the surface. That means if the surface is opaque in nature, here the intensity of the light is very high, but if the surface is non-opaque, then the light intensity is very low. And after that, the intensity of ambient light uniform at every point may be different for every surface, and color RGB. That means if the all over the picture elements or object elements that to be black and white color, so in this case the intensity to be equal in every pixel points. But if the opaque given surface to be RGB color, then here the intensity of the lights is different. Okay. So in this case we have to use two factors for calculating the intensity. That's your the intensity of an object here at a given point due to self luminosity is to be calculated by using two intensity factors. One is I and another one is the IA and another one is the KA, and here I is the intensity of reflected ambient light. Here I is the intensity of reflected ambient light and IA is the intensity of ambient light, and when we have to finding the intensity of reflected ambient light, here we have to assume some constant ambient light intensity, that's your KA, and another one is the IA, which is to be actual intensity of ambient light. When that to be multipliers, then after that we have to creating the, then we have to calculate the intensity value of the given object. Okay. So that's about your ambient informations. So now goes to our next concept, that's your surface lighting effect. That means when the ambient models to be calculating all over the light intensity of the given object, then how the surface lighting effects to be produced. Here the amount of incident light reflected by a surface depends on the type of materials, that to be luminous or non-luminous. Then after that if that to be shining materials, that means that to be luminous in natures, opaque in natures, here reflects more of the incident light, and dull surface absorbs more of the incident light. If the given metals to be shining in natures, compulsory any types of dull surfaces also absorbs more of the incident lights. Then after, for transparent surface, some of the light is also transmitted through the materials. If that to be opaque in natures, and also opaque in natures looks like your mirrors, then here all over the incident lights that to be traveling from internally to viewing another types of materials. Okay, so that's your surface lighting effect. Now go to our next concept, that's your diffuse reflection and perfect diffuse reflection illumination models. Here the surfaces that are rough or grainy tend to reflect light in all directions, and after that in this case this scattered light is also called diffuse reflections, and here surfaces that reflect incident light with equal intensity in all directions, and it is a case perfect diffuse reflections. That means here the surfaces are referred to as ideal diffuse reflectors, for examples like your snow, movie screens. Okay, and after that here the surfaces looks like your labyrinthine, which is to be absorbing equal amount of light in every directions. Okay, and then after why that to be reflecting, because they reflect light from equal intensity in all directions, so that is to be that to be viewing all over the object and diffused format. That means in case of diffuse reflection illumination models, here when the light to be view of above the part of object screens, the object screens to be non-luminous in natures, that means non-opaque in natures. Maybe by using the given reflecting lights another object we cannot be view of. So that in this case this types of models to be known as that's your diffused models. And another concept that to be provides, if the given object that to be placed over the surface which is to be maybe luminous, but it cannot be provided for viewing another object through the given object reflection light. Why? Because in this case all over the light, because in this case the given diffuse object to be absorbing intensity in every directions in equal amount, so that we cannot be easily evaluate the approximately one individual intensity through which another one reflection light to be created through which another object we have to view of. Okay, so now goes to our next concept, that's your specular reflections. Specular reflection illumination models. That means here a perfect mirror reflects lights only in the specular reflection directions, and here other object exhibits specular reflection over a finite range of viewing position around vector R. That means here one type of shining surface and it's one type of dull surface, and specially the specular reflection concepts to be used if the given surface to be very shining in natures, that means the object to be placed over shining surface, when the light to be reflected above this part, in this case all over the objects to be viewing in directly, and by using this given object reflection lights we have to easily view of another types of object. We very deeply counting all over the pixel points in finite number of range. But if the given surface dull in natures, here maybe the specular reflection cannot be functions, because the specular reflection always reflects light only in specular reflection directions if the object to be very strong. That means the object to be placed above very strong surface. In this case we have to use the specular reflections. That means the specular reflection is when the reflection is stronger in one viewing directions. That is, there is a bright spot called rectangular called a specular highlight. That means this is readily apparent on shining surface. For an ideal reflector such as mirror, where the angle of incidence equal the angle of specular reflections. So that easily we have to view of. And here the light is reflected mainly in the direction of the reflected rays and is attenuated by the amount dependent upon the physical properties of the surface. And since the light is reflected from the surface is mainly in the direction of the reflected ray, the position of the observer determines the perceived illumination of the surface. And specular reflection here models the light reflecting properties of sign or mirror like surfaces. That means in case of specular reflection illumination models, if we have to require for calculating the light intensity of the given surfaces of the object, if we have to use the specular reflections, here compulsory the surface to be luminous in natures, that means shining in natures. When the light to be observing, it to be reflecting some other lights through which we have to viewing another object in very easily. That means the surface is very strong, for example like mirrors. That means when any types of lights to be reflected above the part of mirrors, the mirror to be directly reflecting another object in that given intensity, those that to be capturing. Okay, and this types of modeling concept for calculating the intensity we have to use the specular illumination models. So now to check here how the specular reflections to be reflected the strong object. Here in a specular reflection it may be possible that some portion of the surface generated more light or may be produced bright spots. That means as here is the shining surface, so whenever the light to be reflected, the light to be incident above the given surfaces, maybe it to be created some bright spot. Okay, and this is types of creation data scanning to be known as specular reflections. So now goes to our next concept, that's your example of some specular reflections like your metal surface, mirror, any types of sign plastics, and gold and silver coated surfaces and shining apple surfaces. These are all strong examples, strong surface examples through which when the light to be incident upon, then it to be created some reflecting light through which another object to be view of. Okay, so now goes to our next concept, that's your example of some graphical example of specular reflections. It's one type of metallic materials where the light to be focusing, then it to be reflect for viewing another types of object. Then goes to our next examples. Check here one types of circular objects that to be provided where some portions are dull in natures, maybe diffuse in natures, and some portions are ambient in nature. That means we have to viewing the object, but that may be created some very partial portion of the light through which another object we have to viewing its shadow positions like your ambient, and that's your diffuse, maybe that cannot be provides any types of reflecting space for viewing another object. And that's your specular, that means when the light to be reflected above the given strong surface, shining surface, then it to be created one type of bright spot through which another object we have to view of, and that's your speculars. Okay, so in today's class we have to learn about the illumination models. As I will express just before, the illumination models to be known as that's your light models, and also sometimes to be known as that's your shadow models. Why it is to be known as lighting models? Because when the light to be incident upon any object, if after that the object to be reflecting some light through which another object to be view of, in this case we have to use for calculating the given intensity, that's your illumination models. After that we have to learn how the intensity of the light sources of the given object to be calculated by using different technique, different models like your ambient, and another one is the diffuse, and the last one is the speculars. In case of ambient models, here this models to be used if the light to be incident upon any types of shining object that may be not strong, but that's to be shining. That means here the shining object, when light to be observing, then it to be providing some reflections through which another object to be view of. But the another object whenever we have to view of, that cannot be providing for calculating its depth intensity value. Then after we have to learn that's your diffuse models. In case of diffuse illumination models, here the intensity to be calculated if any object that to be diffusing, that means that cannot be creating any types of reflecting lights when the light to be incident upon it, and in this types of object intensity to be calculated by using your diffusion models. Then after we have to learn that your specular illumination model. By using the specular illumination models, we have to calculating the intensity value in very easily. Why? Because here the incident object rays, they are sure very strong, that means that to be very luminous. When the light to be incident upon the strong luminous materials, then instantly the light luminous object materials to be creating some reflecting lights, and which to be looks like your any types of bright spot, through which we have to easily calculate another types of object intensity. Okay. So for today's class, that's all. If any conflict or confused about your illumination model, then you can ask me with the help of comment box. That's all. Thank you now.